you guys. Today I'm going to just tell you really quick a little bit about what you're going to need to know as far as slope-intercept form. Now, in class earlier this week, we did quite a bit of practice with solving equations for y, getting them to say y equals. I hounded you about making sure that you always put your variable term first, which was your x term, and then having your constant second. That was all for good reason. Today when we look at something called slope-intercept form, y equals mx plus b, it's important to realize what a couple of these letters mean. M is always going to be used to refer to your slope. Okay, now we know that slope is rise over run. So M equals rise over run. Whenever I find that value for a given problem, whether a graph or given a table, that value is always going to go into my M in front of the x in the equation. The B is always going to be used to represent now our y-intercept. Now remember, y-intercept is where the graph crosses the y-axis. So at what point does the graph touch or go through the y-axis? Okay, now I want us to look at one example here. I have a graph, the amount of flour that's in a bag. My x-axis, I have the days since I purchased that bag of flour, and the y-axis, I have the weight of the flour. So as you know, when you buy a bag of flour, as the days go on that you're using it, the amount that's left is going to go down. So I have a line here that's decreasing. Okay, that tells me I'm going to have a negative slope. Okay, so if I try and find the rise over the run for this, because my goal is to write an equation, y equals mx plus b, because I'm going to be able to use that equation to help me get other information that I need. The m, the slope, I calculate how much do I rise. So I'm going to start at my lower point, 5, 4, and I'm going to see I rise, remember how bad my smartboard is, I rise from my dot, I go up. How much? I'm going from 4 to 4.6. That's a rise of 0.6. Now, how much do I run? To get to my run, I have to go to the left. So I go to the left, how much to get there? Well, I'm going from 5 to 2. 5 minus 2 gives me 3, but I went to the left. Going to the left is negative, so I have divided by negative 3. So my slope for this line is 0.66 divided by negative 3, which equals out to be negative 2 tenths. So that's what my slope is. So I know when I write my equation that I'm going to replace this negative 2 tenths for that m. Now, the b is real simple. When I have a graph, my y-intercept is simply going to be that point, the point where my line crosses the y-axis, which is at where? 5. So when I write my equation would be y equals my m, my slope, negative 2 tenths x plus my y-intercept, which is 5. So that would be the equation for this line, the amount of flour in a bag. Now, if I want to use this equation to estimate or to find the answer to a couple things, let's say I want to know the weight of the flour after, let's say, 8 days. After 8 days, I want to use my equation to predict what the weight of the flour would be. So my x-axis is 8. So I'm going to simply substitute my weight is y, so y equals negative 2 tenths times 8 days, and I need to add 5 to that. Well, negative 2 tenths times 8 just gives me negative 1.6 plus 5, and that gives me 3.4. So using my equation, I was able to predict or tell, not even predict, but be able to know with certainty that there would be 3.4 pounds of flour left after 8 days. Similarly, if I want to know how many days since I purchased, would the weight of the flour have been 4.2 pounds? Well, now I'm talking about the weight, which is the y, so I would plug in, say, 4.2 for my y, and then I would want to be solving for x. We all can solve that equation for x. If I want to know how many days since purchased is the weight going to be 4.2. So as you can see, writing equations in slope-intercept form will be very helpful when we need to get certain data from a given situation. That is all. See you guys.